So this is the online worksheet for transformations, which is at grades 4 and 5. So this is everyone's necessary information, foundation and higher. Our first question asks us to describe some translations. So remember, translations are when we have picked the shape up and put it down in exactly the same orientation. We haven't flipped it, we haven't rotated it, we haven't changed the size, and it's shown by a vector. And in the vector, the top number in the vector tells us movement in the x direction, which means right or left. And the second number in the vector tells us movement in the y direction, which is either up or down. Right is positive and up is positive, which of course means left is negative and down is negative. That at least makes sense. When you are translating, choose one corner of the shape. I usually either choose the top corner or the bottom corner. In this case, I'm going to choose the top corner. Here. So the top corner of A to the top corner of B, which is over here. So in order to do that, I want to go 1, 2, 3 spaces to the right, positive 3 on top, and I want to go 2 spaces up, positive 2 on the bottom. And that will take me to the top of B. I could check that by looking at another vertex, another corner, the bottom corner of 1, 2, 3, 1, 2, perfect. What about A to C? So this time, still going to use the same corner. I'm going to go left 1, that's negative 1. And then I'm going to go down 7 and 2, so that's down 9. So both of those are negative. Now to go from C to B, I have to go across first, so I go to the right, so I'm going to go 1, 2, 3, 4. These lines are so faint, it's very difficult to see. 4 across to the right, and then how many up? Well, it's 2 up to 0, and then it's up to 9, so that's up 11, positive 11. It then wants you to describe an enlargement from A to D. It wants to know the scale factor, and it wants to know the centre. So scale factor is the easy bit. We look for a side, so I'm going to use this side on A, and we look for the corresponding side on D, which is this side here. And it's double the length, so the scale factor is 2. If it was 3 times the length, it would be 3, and so on. Be careful, remember, if the shape's getting smaller, it's still classed as an enlargement, but the scale factor will be a fraction. And to find the centre of enlargement, what we do is we join up the corresponding vertices of both the image and the object. So we do that. So I'm going to join up the left-hand vertex of both, extending the line both ways, and I'm going to join up the right-hand vertex of both. And you'll see those two lines kind of cross, that's what they should do, at the coordinate 1, 10. So that's going to be the centre of enlargement. So, the next page is asking what type of enlargement it would be. It does say complete the description, but I don't actually think there's a box for that there. The next one's a printout, so it doesn't have boxes. I think the idea would be you would then, in your head, complete it. So which matches A to B? Well, A to B. Could it rotate? No, it could not, because if you have a look, the short nose, if you like, of A is to the left, but if I turn it around, the short nose of B is to the right. So that is not a rotation. Not a rotation. Is it a translation? Well, no, it's pointing in a completely different direction. Definitely not a translation. Which means it must be I'll put the cross in the wrong place. Which means it must be a reflection. Me not watching what I'm writing. Which transformation maps A to C, on the other hand? Now, if you look, A has got the short nose that way and the longer nose that way. If I rotate the page, C has also got the short nose to the left and the long nose to the right. So A and C is a rotation. Apologies for the shadow, by the way. My lights are very bright. So, page 3, we've got a constructing an enlargement, which basically means draw an enlargement. So we're looking at the we're enlarging triangle A by scale factor 1/3. Remember what I said about fractional scale factors? That means that they are smaller. So 1/3. Centre 70, which they've kindly marked on there for me, to give triangle B. So I choose a vertex. I'm going to choose this vertex here. This is my green vertex. To get to my green vertex from my centre of enlargement, I'm going to go 1, 2, 3 to the right and 1, 2, 3 up. But I need to use scale factor 1/3. So instead of 3 to the right, I'm just going to go 1 to the right, because 1/3 of 3 is 1. And 1/3 of 3 is also 1. So I need to go 1 to the right and 1 up. There is my new green vertex. Now, let's choose another vertex. Let's choose this vertex here. That's my new blue vertex. Sorry, that is my blue vertex. To get to my blue vertex, I need to go 1, 2, 3, 4, 5, 6 to the left. And 1, 2, 3 up. So again, I find a third of both of those. I'm going to go 2 to the left and 1 up. 1, 2, 1. Okay. When you've got that, join up the points you've got so far. I'm running out of pens. So using the ruler, you've got one. Obviously, you don't have to worry about this because MyMaths will drag the corners and it draws it for you. Now the final corner, the final vertex. What colours haven't I used? I haven't used red. Let's use red. It's going to be my red vertex. And if you have a look, my red vertex is directly above. But how far above is it? It's 9 above. So it's 9 up. 1/3 of 9 up would be 3 up. So I'm going to count from there. 1, 2, 3. There's my third vertex. Draw it. Lovely. How do we check? We check using our rays of enlargement. Line up the corresponding vertices and the centre of enlargement. Are they in a nice straight line? Yes, they are. Check the green ones. Yes, they are, which means that I've probably done it correctly, which is useful. It then asks you, be careful here, describe the enlargement maps from triangle B to A. So remember this, ignore that, because that's pretend. That's our B. How do I get from B to A? Now, is it bigger or smaller? It's a lot bigger. So we've got an integer scale factor, and because it was 1/3 to go from A to B, it's going to be 3 to go from B to A. And the centre of enlargement, well, it's exactly the same as it was before. It's still 7, 0. So this is the reciprocal of the scale factor for our original enlargement, and the centre is exactly the same.